This is a short video explaining the solutions for assignment 2. I'll go over each problem and explain the main steps of how to get to the answer. Okay, so let's get started. So I'm going to show you the first question. This is the first question in assignment 2. It involves a delta function, and you're asked to integrate the product of f of t and delta t minus 1 from 0 to 4, where f of t is a continuous function over the real line. Okay, so let's try that. So this is solutions for week 2's assignment. Okay. So the first question asks you to evaluate this integral from 0 to 4 f of t delta t minus 1 dt. Okay. So one needs to use one of the properties of the delta function, and it is also mentioned that f of t is continuous. Okay. So one of the properties of the delta function that you need to use here is this sifting property, integral minus infinity to infinity f of t delta of t dt equals f of 0. Okay. So now if you look at this integral very closely, the limits minus infinity to infinity can actually be replaced by any interval which includes t equals 0. Okay. So as long as the interval includes t equals 0, the same property is satisfied. So in fact, you can use an equivalent version, which is integral 0 minus to 0 plus f of t delta of t dt equals f of 0. So as long as the interval over which you are integrating includes t equals 0, this property is true. So now in this question, the only change is that instead of delta of t, you have delta of t minus 1. So all you have to do is to use a substitution t prime equals t minus 1. So if you use the substitution t prime equals t minus 1, you have to equivalently replace t by t prime plus 1. Okay. And the limits also change. The limits go to from t equals 0 to t equals 4. T equals 0 is t prime equals minus 1, right, and t equals 4 is t prime equals 3. Okay, that is the integral, and then f of t I have to replace with t prime plus 1, and then delta of t minus 1 becomes delta of t prime, dt is the same as dt prime. So you get this integral. So now instead of f of t there, we have f of t prime plus 1. All you have to do is put t prime equal to 0 here, and that equates to f of 0 plus 1, which is actually f of 1. Okay. So these are the simple steps for solving this problem. One needs to use this sifting property of the delta function, that you integrate around an interval which contains the singularity f of t times delta of t, where f of t is any continuous function. You simply get f of 0 as the answer. You simply get f of 0 as the answer. Okay. So that is the way to solve the first question. Hopefully this is clear. Okay. So let us move on to the second question, which I have right here. Okay. So this is an interesting little question, which is quite simple actually. It says, mathematically, what is the time required for the transients to decay to 0 in a linear system? The main idea here is that the way the transients decay to 0 in a linear system is exponential. Okay. So if you look at the second question, you know the transients decay to 0 as e power minus some constant into t, okay, some positive constant into t. Okay. So when will e power minus at be equal to 0? E power minus at is equal to 0 for actually no value of t, and it becomes equal to 0 only when t tends to infinity. Okay. So this is a rough way of writing what I want to say. So, I am saying e power minus at is approximately 0 for t tending to infinity. So, mathematically the correct answer for when the transients die down is actually t equals infinity. Okay. So, it is quite a simple answer. The main thing to know is that the exponential is always positive and goes to 0 only when t is infinity, when a is positive. Okay. So, that is the main idea behind problem number 2. It is quite a simple question. Okay. So, let us move on to question number 3, which is a little bit more involved. The question says you need to find Vc of t, okay, for t greater than 0 in the following circuit, and you are given that Vc of 0 minus is 6 volts. Okay. So, this is your circuit. Okay. So, let me redraw the circuit once again. The circuit is actually quite simple. It has an voltage source 20 volts it says, and then 20 volts connected to a switch which is thrown on at t equals 0. Then you have a resistor which is R, and then you have a capacitor which is C, I guess, and then you have the circuit closing. So, now the voltage across the capacitance is Vc of t, and you are asked to find Vc of t. Okay. So, this is a standard exercise in basic circuit theory, and we know that Vc of t is of this form, a plus b e power minus t by RC. Okay. We know that Vc of t is of this form, and I am not going to show the steps for showing this. You have to write a basic differential equation and solve an RC circuit. We know definitely that Vc of t is of this form, and the information that is given to you is that Vc of 0 minus is 6 volts, and you can also gather from the circuit that as t tends to infinity, okay, for after a long time has passed, eventually the current will die down and the capacitor will get fully charged, which means Vc of infinity is actually 20. Okay. So, now since this is a capacitance and this is a simple circuit with just one capacitance, Vc of 0 minus and Vc of 0 plus are the same. Okay. The voltage across the capacitance will not see a jump. Okay. So, this is what it is going to be, and you have the initial and final conditions. You know, Vc of 0 is 6 volts, Vc of infinity is 20 volts. Now, it is just a question of plugging it into this form a plus b e power minus t by RC and solving for it. Okay. Now, this equation will give you a plus b e power 0 equals 6, and then this equation will give you a plus b e power minus infinity equals 20. Okay. Now, a plus b e power 0 is 1. So, you have a plus b equals 6, and here e power minus infinity is actually 0. So, you simply have a equals 20. Okay. So, a is 20, a plus b is 6. So, you use this here and you get b equals minus 14. Okay. So, overall the answer is going to be Vc of t equals 20 minus 14 e power minus t by RC. Okay. So, it is a simple question of using the initial and final conditions in the form of the answer that you know and figuring out what the actual correct answer could be. And in fact, it is a multiple choice question. So, you can rule out all the other possibilities and pick the correct answer. Okay. So, let us move on to question 4. Okay. So, this again involves a circuit, and this is the circuit that is given to you. There is a voltage source Vs, and there is a resistance 2 ohms and a capacitance 3 farad in series, and you have to find Vs of t, and Vc of t is given to you. Okay. So, that is the problem. So, let me redraw that once again here. You have Vs of t, resistance which is 2 ohms, capacitance which is 3 farad, and you have a Vc of t, and the form of Vc of t is given to you. Let me look it up once again, 10 R of t minus 2 R of 2 t minus 1. Okay. Okay. R of t is the ramp function, and you might want to sketch this. It is not really too hard to sketch this function, it is an interesting function to sketch. Okay. But really we do not need all that. For Vs of t, let us say the I of t is the current that is flowing through this circuit, and of course I think you also have that there is a switch, there is no switch, it is just a formula. Okay. So this is the circuit that we have here. There is a voltage source which is connected to a 2 ohm resistance and a 3 farad capacitance, and the voltage across the capacitance is given as a function of time in terms of ramp functions. So now if you simply write a loop equation, you know Vs of t is going to be 2 times I of t, which is the I of t is the current flowing in this circuit, plus Vc of t. Okay. Vc of t is given to you, and all you have to do is find I of t, and you know clearly I of t is going to be C times dVc of t by dt. Okay. And the C is 3 farad times dVc of t by dt. You simply have to differentiate this. Now, if you differentiate this, you know that the derivative of R of t is actually u of t, right. R of t is t times u of t, and then if you differentiate it, you simply get u of t. And for R of 2t minus 1, you simply have to use one of the simple chain rule properties of the differentiation. You will get u of 2t minus 1 times the derivative of R of derivative of 2t minus 1, which is again 2. So I am just going to do the differentiation here, and you can see that's how it works. Okay, 10 times u of t minus 2 times u of 2t minus 1, and then you have to do a differentiation of 2t minus 1, so you get an additional factor of 2. Okay. So that is the current, and you can go ahead and simplify this. You get 30 times u of t minus 12 times u of 2t minus 1. This is I of t. Now, you plug this back in here and then put in Vc of t, you simply get 2 times I of t. So, 2 times 30 u of t minus 12 u of 2t minus 1 plus Vc of t, which is 10 times R of t minus 2 R 2t minus 1. So, you simplify this, you can rewrite it a little bit, you will get 10 R of t minus 2 R of 2t minus 1 plus 60 times u of t minus 24 times u of 2t minus 1, and that is the correct answer for the 4th question. Okay, so let us move on to the 5th question. Okay, so the 5th question is a little bit involved. I am going to go in some detail and solve this question. So, this is basically a circuit, and one needs to figure out the differential equation involving I1 and Vs. So, now one of the points of doing such problems is to point out that later on you will find more powerful, and you will learn about more powerful Laplace transform type methods for solving these problems very easily. But when you do not do that, you have to just basically write down some equations and solve. It is not basically very difficult, but the algebra involved can be a bit intense sometimes. So, let me show you how to do this, and we have given you some hints for how to do it, but I guess when you see one solution, you will get an idea of how to work these kind of problems. So, let me redraw this circuit once again. So, for some reason I am not able to cut and paste this circuit. So, I am going to redraw this circuit once again. Let me just make sure I memorize this. Okay. So, that is fine. So, this is question number 5. You have a voltage source Vs, and there is a switch. Let me just go back and forth here just to make sure. There is a 1 ohm resistance, and there is a 4 Henry inductance, and a 2 ohm resistance, and a 0.5 farad capacitance. And this is Vs, and the current in the first loop is I1, the current in the second loop is denoted I2, and you have to find a differential equation relating I1 and Vs. Okay, so, it is just a question of writing the 2 loop equations and figuring out how to go about it. If you write the first loop equation, you know Vs is going to be equal to I1, which is the R times I1, but R is simply 1 ohm. So, this is just I1 plus L times d current in the inductor, d by dt of the current in the inductor. Now, the current in the inductor is I1 minus I2. So, I need to do d by dt of I1 minus I2, and my d by dt I am denoting it as capital D. So, I get I1 minus I2. This is one loop equation. The other loop equation I am going to write for the entire big loop. Okay. So, that is going to be Vs equals I1 plus 2 times I2 plus the voltage across the capacitance. Now, the voltage across the capacitance I want to write in terms of the current. So, if you look at it, I2 is going to be C dV by dt, dVc by dt. So, this Vc, if you want to write, it needs to be 1 by C integral I2 dt, right, and this we are denoting as d inverse. So, it is going to be just 1 by C d inverse I2, and C is actually 0.5. So, 1 by C is going to be 2 times d inverse I2. So, that is the Vc, and that is what we will write here. Okay. So, now one can multiply this throughout by d, and you get dVs equals di1 plus 2d I2 plus 2I2. Okay. So, now this equation, if you want, you can simplify. This is going to be Vs equals I1 plus 4di1 minus 4di2. Okay. So, I have two equations. It has I1, I2 and Vs. I want a relationship between Vs and I1, which means I have to eliminate I2 from this equation. Okay. So, you can do it in multiple ways. So, what I am going to do is I am going to take this equation and eliminate I2 from it. Okay. So, what I can do is I can multiply throughout by d inverse and push this term to this side. So, I will get 4 times di2 equals I1 plus 4d I1 minus Vs. Now, I multiply throughout by d inverse, I get 4 times I2 equals d inverse I1 plus 4 I1 minus d inverse Vs. Okay. So, these two are important equations. We can use this equation, plug it in here to get the answers, because we have a di2 and we have a I2 here. Instead of I2, I am going to plug in from here. Instead of di2, I am going to plug in from here. Okay. So, I have 4 di2 and 4 I2 here. So, maybe I need to multiply this equation by 2. So, if I do that, I get 2 dVs equals 2 di1 plus 4 di2 plus 4 I2, and now I can directly plug in what I have here. So, this is going to be 2 di1 plus I1 plus 4 di1 minus Vs, and then for 4 I2 I need to plug in something else. I get here d inverse I1 plus 4 I1 minus d inverse Vs. Okay. So, that is it. So, we now have an equation involving Vs and I1. Now, I need to multiply by d and make sure everything works out correctly. Okay. So, I am going to do that. If I do that, I get 2 d squared Vs and then plus dVs plus Vs. Okay. So, I am also moving the terms corresponding to the left hand side. Hopefully, you can see what I am doing here, and equals. So, there is a 2 di1 here, 4 di1 here, totally 6 di1. When I multiply by d, it becomes 6 d squared I1, and then 5 I1. There is an I1 here, there is a 4 I1 here, that is 5 I1. When I multiply by d, I get a 5 d I1, and then there is a d inverse, which gives you an I1. Okay. So, that is the equation relating Vs and I1. Okay. So, it is mostly algebra, but at the same time, if we have not done it before, it will be a little bit intense, and it is good to get some practice for it. Okay. So, let us move on to question number 6. Okay. So, question number 6 is really nice, and it is a discrete time LTI system, and the input output relationship is given to you. The input is given to you, initial conditions are given to you. You have to find the output of the system at n equals 3. One of the points of this question is to just illustrate to you that discrete time systems are really simple when compared to continuous time systems. You simply have an equation, you plug in one after the other, and you will get the answer. Okay. So, let me write down what this is. Okay. So, the question says y of n minus 4, is it minus? Let me just check, minus 4 y n minus 1 plus 4 y n minus 2 is equal to x n. Okay. This is your discrete time difference equation relating input and output, and the input x n is given to be 0 for n less than 0, it is given to be 2 power n for n greater than or equal to 0. So, basically x of n goes as x of 0 equals 1, x of minus 1 and all that is 0, so on, and then x of 1 is 2, x of 2 is 4, and actually the question asks you to find y of 3, the question asks you to find y of 3, and you really need to know only up to x of 3 for it. Okay. So, one can just find one after the other. So, you put n equals 0, okay, and actually the initial conditions being 0 also means that y of minus 1 equals y of minus 2, etc., all of them are 0. Okay. So, if you put n equals 0, you get y of 0 minus 4 y of minus 1 plus 4 y of minus 2 equals x of 0. Now, this guy is 0, right, and this guy is also 0. So, you basically get y of 0 equals x of 0, which is just 1. So, now you put n equals 1, okay, and you get y of 1 minus 4 y of 0 plus 4 y of minus 1 equals x of 1. So, you get y of 1 minus 4 times 1 plus 4 times 0 equals x of 1, which is 2. So, now you solve this out, you get y of 1 equals 6. Now, you put n equals 2, okay, you get y of 2 minus 4 y of 1 plus 4 y of 0 equals x of 2. Just a simple solution, but nevertheless I am just writing it down for your convenience. 4 into 6 plus 4 into 1 equals x of 2, which is 4. So, if you solve this, you get y of 2 equals, this 4 will cancel and you simply get 24. Okay. And then the final step is to put n equals 3. I am going to do it a little fast. Y of 3 minus 4 times y of 2, which is 24, okay, plus 4 times y of 1, which is 6, equals x of 3, which is 8. So, now that gives you y of 3 equals 80. Okay. You can solve this. So, like I said, the main point is to see that discrete time input output relations are really quite simple. You can just plug in values and get the answer. Okay. So, let us move on to question number 7. Okay. So, question number 7 involves a inductor loop, okay, initial conditions for an inductor loop. Now, these problems are solved in your assignment, but I am going to quickly do the solution for this. Okay. So, the circuit below is allowed to reach steady state before time t equal to 0 with the switch S1 remaining closed. Okay. So, let us see the circuit once again. So, the switch S1 is closed and it is allowed to reach steady state. Okay. So, once it reaches steady state, if you notice, the current through the inductor L1 is going to be 0. So, in steady state before the switch before t equal to 0, just before t equal to 0, the current that is flowing in this circuit will actually be 1 ampere, okay, because this is closed. So, this resistor will play no part. So, the current that is flowing in this circuit before t equal to 0 is actually 1 ampere. Okay. So, maybe I should just draw this circuit once again and make the argument here. Okay. So, this is the 7th question, and the circuit goes as this. There is a 3 volt supply, and then there is a 3 ohm resistance, and then there is a 1 Henry inductance, and then there is a 1 Henry inductance here again with along with some resistance. I believe it is 1 ohm, it is not so crucial. And then there is a circuit, there is a switch here, okay, S1. So, S1 remains closed for t less than 0. So, t less than 0, the current is actually 3 by 3, which is actually 1 ampere. How did I get that? Because for t less than 0, the switch is closed, S1 is closed. So, really the circuit is simply 3 ohm, 1 Henry, and then this is actually closed. So, it will just come here. So, that other part will get bypassed out. Okay. So, there is no element in this is just a short circuit. So, the other part gets short circuited out. So, this is just the circuit, and this is allowed to reach steady state. In steady state, the inductor is a closed circuit. So, it just allows all the current to go through. So, the only current in this in this is this potential, the only potential difference shows up on the resistor. So, the current is simply 3 by 3, which is 1 ampere. Okay. So, the current that flows for t less than 0, so t equal to 0 minus current equals 1 ampere. Okay. So, now at t equal to 0 plus, there is an inductor loop here. So, some impulsive action is going to happen, and some final current will flow, some current will flow in the circuit for t equal to 0 plus. So, t equal to 0 plus, let us say that the current is I amperes. Okay. So, if the current is I ampere, then you are going to have 1 minus I as the delta of t as the impulsive voltage across across the first inductor. Okay. So, maybe I should name these inductors. Yeah, it is named as L1 and L2, this one is L1, this one is L2. So, L1 has this inductive impulsive voltage across it, impulsive voltage across it. Okay, at from 0 minus to 0 plus, it will have a 1 minus I. Why is this 1 minus I? 1 is the current flowing before 0. Okay, so, let us look at the current through the inductor L1, IL1 of t, and for t less than 0, it is allowed to reach steady state at 1 ampere, okay, which is what I showed here. And let us say at t equal to 0 plus, the current is I. Okay, it starts like that, somewhere around here I. Okay. So, now the voltage, the impulsive voltage is actually L times d IL1 of t by dt, right, and that is going to be 1 minus I delta of t, and you have to take a suitable direction there. I am taking the direction the other way. Okay. So, I am looking at it the other way. So, it goes 1 minus I delta of t, and L is equal to 1. So, simply that is the impulsive voltage. Now, on the other hand, if you look at L2, okay, L2 has 0 current flowing through it for t equal to 0 minus. So, if you look at L2, it has 0 current flowing on it for 0 minus, and at 0 plus it has a current I flowing through it. Okay, it has a current I flowing through it at 0 plus. Okay, so, something happens at 0 plus, but at 0 plus it has a current I flowing through it. So, for L2, the corresponding impulsive voltage is I times delta of t. Once again, I have to do L times d I L2 of t by dt, and that gives me the impulse I delta of t. This is the impulsive voltage across L2. Okay. So, now for the circuit voltage equations to be satisfied, these two voltages have to be the same, they have to cancel, they will be in different directions because current will be flowing, will be reducing in one, it will be increasing in the other, one will be positive, the other will be negative, they will cancel each other out, and for them to cancel each other out, you need to have 1 minus I equals I, which implies I equals half ampere. Okay. So, you notice the other this 1 ohm circuit, 1 ohm value did not really play a role, it does not play a role in the current for at 0 plus. Okay, at 0 plus the whatever current is there, it does not play a role, beyond that it will play a role. Okay. So, our current the correct answer for this question is I equals half ampere, and these kind of problems are described in detail in the lectures by Professor V.G.K. Murthy as well. I will invite you to look at them, but this is the way to solve it. So, you have to look at the current change across the inductors in the loop, and you have to kind of equate the impulsive things to 0. Okay. So, let us move on to question 8. Okay. So, question 8 is on convolution. Y of t is x of t convolved with h of t, and you are asked to figure out if the other conditions are true or not. Okay. So, y of t is x of t convolved with h of t, and you can write that as integral minus infinity to infinity x of tau h of t minus tau d tau. You can also write it in so many other ways, but this is one way of writing it. So, the first part of the question asks you to check if 2 times x of t convolved with h of t equals 2 times y of t. So, it is not too hard. So, you here to check the first part, you look at 2 times x of t convolved with h of t. So, remember this is the entire function. So, if I do that, okay, so if you write this out, get integral minus infinity to infinity 2 times x of tau h of t minus tau d tau, and that is clearly 2 times y of t. Okay. So, the first part checks out. The second part asks you to check x of t minus 2 convolved with h of t, is that y of t minus 2. So, if you write x of t minus 2 convolved with h of t, you get integral minus infinity to infinity. Instead of x of tau, I will get x of tau minus 2 h of t minus. Okay, so, this is t minus tau t tau. Okay. So, now here this is so now I have to relate this to the y of t. For this you will need like a substitution. Let's put tau prime equals tau minus 2. So, if you do that, you get integral minus infinity to infinity, limits do not change because it is infinity, and here you have tau prime. For h you will get t minus, so this means tau is tau prime plus 2, right. So, you have to replace this with tau prime plus 2, tau prime minus 2, and then d tau is the same as d tau prime. So, you simply put d tau prime. So, if you rewrite this, you do a change of variable, exchange tau to tau prime, do a change of variable, it is just a dummy variable here. So, you can call it anything else, you simply get x of t, and here I will rewrite it a little bit, h of t minus 2 minus tau t tau. So, now you can look at the expression for y of t and relate these two guys, and you will see this is exactly the same as y of t minus 2. Okay. So, these two equations check out, first and second options are correct, and for the third and fourth options I will let you do the simplification. You can quickly see that this will not be true, both of them are not true. Y of t need not be same as y of minus t, there are easily the convolution need not be even at all, and even here you can verify that this will not be true. Okay. So, this involves a little bit of work, you have to write the integral carefully, and you will see that these two are not true. Okay. Now, the ninth question is a simple definition of convolution. What is the steps in the convolution? You have to first flip, right. So, if you look at the convolution equation, so let me write that down. Ninth question, if you want to convolve x of t with h of t, basically it is integral minus infinity to infinity x of tau h of t minus tau d tau. Okay. So, you have to first go from h of tau to h of minus tau, and then you go to h of t minus tau. So, the first step is flip, the second step is shift, and the third step is to multiply. Okay. So, x of tau multiplied by h of t minus tau, this is multiply, and finally integrate to get minus infinity to infinity x of tau h of t minus tau d tau. Okay. So, flip, shift, multiply, integrate, and you can see that goes as 3, 2, 1, 4, and 3, 2, 1, 4 is option number 3 in this question. Okay. So, that is the correct answer, it is 3, 2, 1, 4. Okay. So, that is question number 9. Let us move on to question number 10. Okay. So, these are okay. So, this is a question which is quite simple, bread and butter question for LTI systems. It is quite common, a lot of people ask these questions. So, the impulse response of an LTI system is given to you, and you are given an input signal x of t, and you have to find the response. Okay. So, you have to find the response, and we are asking you for some constants in the response. Okay. So, if you find the response, you can easily pull out this constant. Okay. So, let's just write that question once again. I am sorry, h of t is e power minus 3t ut. Okay. So, that is question number 10. The impulse response is given as e power minus 3t ut, and then x of t is given as e power minus 2t ut, and you simply have to compute the convolution, right. So, the response y of t is simply the convolution of x of t with h of t. You simply have to do the flip slip kind of operation. So, it is good to sketch these things. I always like to sketch these things one below the other in a suitable way, and then you will see what to do. Okay. H of t starts at 1 and goes down to 0 exponentially. So, this is h of t, and then x of t starts at 1 again and then goes down to 0, maybe not as rapidly, a little bit less rapidly, I do not know. So, this is h of t is e power minus 3t, x of t is e power minus 2t. Okay. So, that is the plot, and one needs to convolve these two guys. So, when you convolve, you have to do the flip, multiply, slip operation. So, let me do the flip and multiply on h of t. So, h of minus t is going to be like this, and this guy is going to be h of minus tau. Okay, you can put it against tau if you like, and then you shift it by t. Now, you see immediately any left shift of h of minus tau. Okay, so, for t less than 0, if you do a left shift, the multiplication is going to simply give you nothing. Okay. So, you want the multiplication to give something, so you have to shift by to the right, which means t should be positive. So, it is enough if you assume t greater than 0. So, if you do that, you will get something like this. Okay. So, this is the shift by t, okay. It is 1. So, this is h of t minus tau, okay. And then you multiply these two guys, you will simply get integral from 0 to t e power minus 3 t minus tau times e power minus 2 tau d tau. Okay. So, this guy is h of t minus tau, this guy is x of t, x of tau, sorry. I am simply multiplying these two things together and integrating from 0 to t. It is enough if I integrate from 0 to t, and clearly I am assuming t is greater than 0. For t less than 0, the convolution is 0. Okay. So, now one needs to simply evaluate this. So, you see this integral is actually over tau, and t simply gets out of the picture. So, you can pull the e power minus 3t out, and you simply get integral 0 to t e power 3 tau minus 2 tau d tau. Okay. So, and that is simply I am sorry, let me just write that once again more carefully. That is simply e power minus 3t integral 0 to t e power tau d tau, and the integral e power tau is simply e power tau itself. So, e power minus 3t times e power tau from 0 to t, and that will simply evaluate as e power minus 3t times e power t minus e power 0, and e power 0 is just 1. So, that will simply evaluate to e power minus 2t minus e power minus 3t, and remember this is for t greater than or equal to 0. Okay. And in fact, the convolution y of t finally one can write down in the simple form e power minus 2t minus e power minus 3t times u of t. I can simply write it as times u of t, because for t less than 0 I know the convolution is 0, for t greater than 0 I know it is simply e power minus 2t minus e power minus 3t. Okay. So, now you go back to the question simply asks you that the answer is in the form of a e power minus 2t plus b e power minus 3t. So, you have to identify a and b, and you can simply look up and say a equals 1, b equals minus 1, and 1 comma minus 1 is the answer. Okay. So, that is question number 10. Let us move on to question number 11. Okay. So, this is a simple convolution question. You have to look at x of t and you have to look at h of t and simply carefully do it. You have to do the flip, slip, multiply, integrate operation very carefully, and you can see the answer. Maybe I will do it just for one case and leave the other things for as an exercise. Okay. So, let me do for t equals 1, and then all the other cases I will leave it as an exercise, simply give you the answer. Okay. So, okay. X of t it is good to draw these things very carefully. My pictures do not come out to be very good looking, but nevertheless I try to be as careful as possible and sticking to scale and all that. X of t is simply given as this, and h of t is given as 1 from minus 1 to 1, right. That is the h of t, and then now we need to convolve these two things. Let us say I look for the answer at t equals 0. Okay. So, t equals 0 is a nice thing to look at, and since this h of t is symmetric, it is good to write down the convolution integral minus infinity to infinity x of tau h of t minus tau d tau. Okay. So, the reason why it is good to flip the symmetric, both of them are symmetric, but let us say I flip h of t, because it is 1 from minus 1 to 1, and if you flip you get the same function, nothing changes. Okay. Now, if you put t equal to 0, I have to plot h of, so t is 0 here, so I have to plot h of minus tau from versus tau here. Okay. That is simply going to be the same thing, right. So, it is going to be 1 from minus 1 to 1. Okay. It is h of minus tau is the same as h of tau, and you get this. So, now when you multiply these two guys, you will get as a function of tau, it will be from minus 1 to 1 alone, and simply h is simply just 1. So, there is nothing much to do there, and x is going from minus 1 to 0. So, it is good to see what value x would have at minus 1 and 1, and you can clearly see from the slope that this height would be 1. So, when you multiply these two guys, you go up to 1 and then you rise up to 2 like that, and you get this. This is 1, this is 2, and this is x of tau h of minus tau. Okay, this is for t equal to 0. So, this is what I want. Now, I need to integrate this. Now, when you integrate this, it is just the same as calculating the area under the curve. Okay. So, you only need to find the area under this. This shape is actually a rectangle rectangle and a triangle on top. Okay. What is the area of this rectangle? Okay. The area is the product of the two sides, right, length into breadth. Length is actually 2, breadth is actually 1. So, it is just 2 into 1, which is 2. And what about the area of this triangle? Triangle area is half into base into height. Half into base is actually 2, and then height is actually 1. So, the base is 2 and the height is 1. So, you simply multiply these two guys, you get 1, and the total area equals 3. Okay. So, for t equal to 0, you have to get the answer as 3. Okay. So, you can do a similar calculation for all the other things. The answer works out as follows. The correct answer is actually 0, 2, 3, 2, 0. Okay. So, this is for t equals I believe minus 3, minus 1, 0, 1, 3. This is y of t. Okay. So, you can calculate these things. It is just a simple question of shifting, multiplying, and most of these integrations can be quickly done using these area calculations of rectangles and triangles. You will seldom have to actually evaluate a integral using formulae. Okay. So, let us go through to the last two questions. The 12th one is actually here. Okay. So, once again this is a, like I said, a bread and butter question in LTI systems. In LTI system with impulse response h of t is e power minus 3 t plus 1 u of t is given. What is the output for an input signal? X of t is delta of t plus 3 times u of t. So, it is a straightforward convolution. So, let us do that. Okay. So, h of t is e power minus 3 t plus 1 u t, and the input x of t is delta of t plus 3 u of t. Okay. Let me check that once again, plus 3 u of t, and you have to find the convolution. Okay. So, these kind of convolutions can be done in various ways, and you can use the linearity properties of the convolution. For instance, I know since x of t is delta of t plus 3 times u of t, I can simply write this convolution as delta of t plus 3 u of t convolved with h of t, and that will be delta of t convolved with h of t plus 3 u of t convolved with h of t. Okay. Now, this convolution is very easy, it is same as h of t. So, the only convolution you have to evaluate is this guy. Okay. So, let us just evaluate u of t convolved with h of t. Okay. So, once again h of t starts at t equal to 0. So, if you look at h of t, it starts at e power minus 3 at t equal to 0 and then decays down to 0. Okay, so maybe I did not draw that very well. Let me redraw it. Okay, so it decays down to 0 like that versus t. On the other hand, u of t, you know already how that will look. So it just goes 0 to 1. Okay, that's how it looks. And this is the convolution you have to do, and let me do that. U of t convolved with h of t. Okay, clearly, so it's good to flip the u of t. So you flip the u of t, and then if you take negative t, it's going to go off to 0. Okay, so that is an easy thing to write down. Okay, so you know it's 0 for t less than 0, and for t positive, you will get an integral from 0 to t, and u of t is just 1. You just have to multiply and do e power minus 3 t plus 1 dt. I am sorry, e power minus 3 tau plus 1 dt. So, tau plus 1 d tau. Okay. So, this is the integral you have to evaluate. Hopefully, you see how this comes about. I simply have to do the flip of the u of t. Maybe I can show that to you here. I do a flip of the u of t. Okay, and then this is u of minus tau, and then I shift right to t. Okay, so this guy is u of t minus tau, and so when I multiply, I simply have to integrate h of t, which is actually e power minus 3 t plus 1 u of t from 0 to t. Okay, so that's the answer I get. So this integration has a e power minus 3 coming out, and then e power minus 3 tau, and integral 0 to t e power minus 3 tau d tau, and that will integrate as e power minus 3 tau by minus 3, and that needs to be substituted from 0 to t, and you would simply get e power minus 3 times, you can put tau equals t, you get e power minus 3 t by minus 3 minus e power 0, right, tau equal to 0 by minus 3, and that works out to this minus and minus will cancel, e power 0 is equal to 1. So, you get a 1 by 3 common outside. So, you can pull out e power 3 by 3 times 1 minus e power minus 3 t. Okay, you can check this calculation closely if you like. This is what you would get. And now you go back here and substitute for y of t. Y of t is simply h of t, which is e power minus 3 t plus 1 u of t plus 3 times u of t convolved with this. So, you would just get so I am sorry, this is for t greater than or equal to 0. Okay. So, the convolution also has a u of t multiplying it. So, you simply get e power minus 3 times 1 minus e power minus 3 t u of t. Okay. And you will see the u of t term, the second u of t term will cancel, and you will simply get a e power minus 3 u of t. Okay. So, it is one of those interesting convolutions which convolves two different signals, and you end up getting a flat answer. Okay. So, e power minus 3 constant throughout t. Okay. So, that is the answer for this convolution. It's an easy calculation in one way, but if you haven't done these calculations before, it's good to get this practice. There's lots of steps in the middle, and you have to be very careful not losing track of signs and losing track of the integral limits, etc., because you will get drastically different answers if you make those mistakes. Okay. Finally, we are at the last problem of this assignment. Okay. Once again, it's a evaluation of a convolution, but in this case the convolution evaluation is quite simple. You can use some properties. It says here impulse response of an LTI system is given to be as e power minus t u of t, and the input is actually sum of deltas 2 times delta t plus 1 minus delta of t minus 1. What is the output? Okay, and it's given in a certain form, and you have to find the constants a, b, c, d. Okay. So, let's write that down. Okay, h of t is e power minus t u t. Is that right? Let's check that once again. Yes, and x of t 2 times delta of t plus 1 minus delta t minus 1. Let's check that once again. Okay, so that's the thing. So now we have to convolve to get y of t. Simply x of t convolved with h of t. So this is just 2 times delta of t plus 1 convolved with h of t minus delta of t minus 1 convolved with h of t. Okay. So, now when you convolve something like this, the answer is going to be simply h of t plus 1. The answer here is going to be simply h of t minus 1, right. So, this is one of the properties of the delta function. It simply gives you the function it convolves with. It just simply drops out, and then you get the, instead of t plus 1, whatever you have inside delta, you need to put inside h. This is one of the properties of the delta function. Okay. So, once you have this, it is easy to write down. So, if you write down h of t plus 1, you get 2 times. So, this is just 2 times h of t plus 1 minus h of t minus 1. So, now you just plug in the value you have here, minus t plus 1 u of t plus 1 minus e power minus t minus 1 u of t minus 1, and you can pull the e power minus t out to get the form of the answer. You get 2 times e power minus 1 u of t plus 1 minus e power 1 u of t minus 1, and the answer is in the same form, except that you have e power minus t times a e power b u of t plus 1 plus c e power d u of t minus 1, and that reads simply as a equals 2, b equals minus 1, c equals minus 1, d equals 1. Okay. So, the correct answer you will have to enter is 2 comma minus 1 comma minus 1 comma 1, and you would be correct. Okay. So, that brings us to the end of the solutions for assignment 2. Best wishes for continuing on in the course. Thank you very much.